Now that we know a little bit about what is digital and what is binary, let's kind of dig deep a little bit into the specifics of what it is that we're trying to do with binary, what we're trying to do with a digital circuit. So where we're going to start is we're going to look at numbers. And these numbers is that somehow we're going to want to represent a number as a binary value. And this binary value is going to be either a 0 or a 1. Okay, so before we start talking about numbers, let's talk about, before we start talking about binary numbers, let's talk about digital numbers. And where we're going to start is let's talk about the numbers we deal with every single day. So we use numbers every day, and the numbers that we use every day, these are called base 10, or it might also be referred to as a decimal number. And what this is that if we look at this idea of base 10, the 10 is going to tell us the number of possible digits. So with the digits in base 10, we have a digit called 0, a 1, a 2, 3, 4, 5, 6, 7, 8, and 9. Those are all the possible digits that we have. So think of it as a single place in a number. Now, numbers that we use may be made of multiple digits. Maybe I have a 1-digit number. And what's an example of a 1-digit number? Maybe I just have the number 5. Maybe we can have a 2-digit number. And a 2-digit number, maybe an example of that is 33. Maybe I can have a 4-digit number. A 4-digit number is 2,714. So we can see that we can keep adding in digits to make our number larger. All right, so we can see how the number of digits kind of gives us an idea of how large of a number is. Now let's take something like the 2,714. And this, let's write it out. Okay, so we said it was 2,700. And then we had 14. Okay, all of this is giving us each piece gives us some weight to our number. Well, okay, let's break that down. I had 2,714. These are 4 digits. Each digit has some value to it. Okay, so I have 2,000. Well, that's 2 times 1,000 plus 700. So that's 7 times 100. Now the 14, that's going to be that it's 1 times 10 plus the 4 times a 1. So everything that we multiply by, all of those items are giving us some weight. it is telling us how much that one digit is contributing to the entire overall value. So let's do something a little bit larger. Let's say I had, for example, 37209. So we have these digits, and I want to know, okay, what number is this going to be? All right, so let's start at the rightmost number, because the rightmost numbers, we know these are called our ones place. So I can say, okay, that's 9 times 1. The 0, this is at the tens place. So that's 0 times 10. 2, that's the hundredths place. So 2 times 100. The 7 is thousandths. So 7 times 1,000. And then we'll have 3 times 10,000. Okay, so we can have what all of this weight would be. All right, so let's take this, and since it's base 10, we can represent all of the weights in powers of 10. So the first spot would be 10 to the 0, because anything with a power of 0 is 1. How do I get 10? Would that be 10 to the 1? How do I get 100? That's 10 to the 2. How do I get 1,000? 10 to the 3. And then how do I get 10,000? Well, that would be 10 to the 4. So everything we have is going to have some type of weight to it. So I can kind of break it down that I can say, okay, base 10 weight is the following. Starting at what we're going to call the least significant digit. Well, that's 10 to the 0 in the weight. 10 to the 1. 10 to the 2. 10 to the 3. 10 to the 4. 10 to the 5. 10 to the 6. Okay, so we're going to see that the weight increases as we increase the weight. We see the exponent is 1 larger. All right, this is going to keep reflecting on with binary. So let's talk a little bit about binary now. Binary, we're going to call this base 2. And remember, the base is going to tell us the number of digits we have. So it's going to be the options. So we have an option of a 0 and a 1. We have less digits. It's not 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. No, we have a total of 2. Either that is going to be a 0 or a 1. So with binary, you can have, again, we talked about this last time. We can have a 1-bit binary number. So that might be something just like 1. Maybe we have a 2-bit binary number. And this 2-bit binary number might be 1, 0. Maybe I have a 3-bit binary number. And that 3-bit binary number, maybe that's 1, 0, 1. Maybe I have a 4-bit binary number. And that's 1, 0, 0, 1. So we can see that for each bit, we're going to have one extra digit. Okay, so the number of bits will tell you, how many zeros, how many ones potentially you have in a number. Well, just like decimal had weight, binary has a weight as well. So let's start with this 4-bit. Let's say we have 4 bits. 1001. Well, this 1001 is a number. And since we're not really familiar with binary, we want to know the number as a decimal. What is this number in our regular everyday values? Well, again, I can say that each of these has a weight. And the weight is going to be similar to what we did with decimal. I'm going to take what base I have, and I'm going to give it an increasing exponent. So I start off with the zeros. Well, 2 to the 0, that's 1. 2 to the 1 is 2. 2 to the 2 is 4. And 2 to the 3, that's number 8. So we can kind of call this, on decimal, we said, okay, if I had a 4-digit number, I give each of these a weight. I could say this is the 1 spot, the tens, the 100, the 1,000. Same thing with binary. It's a ones, but now instead of tens, it's called the 2 spot, the 4 spot, and then the 8 spot. All right, so we can keep increasing these values. Okay, so what is 1001? So 1001 as binary, that's going to say, okay, it's 1 times 2 to the 3 plus 0 times 2 to the 2 plus 0 times 2 to the 1 plus 1 times 2 to the 0. Okay, so that's 1 times 8 plus 0 times 4 plus 0 times 2 plus 1 times 1. So it's 8 plus 0 plus 0 plus 1. Well, it adds up to number 9 in decimal. All right, so we're going to use a little subscript so we can tell what kind of number we're talking about. So when we are going to talk about decimal, so I have the number 523, so that I know it's 523 as base 10, and give it a little subscript of 10. Then I have binary. I have 1001. Well, binary is base 2. So I'm going to give a little subscript. So I know this is base 2. And I know that is equal to, a 9 in our base 10. So that way we can kind of move between a binary representation and a decimal representation. Because a lot of times we're going to want to know what these numbers mean in the everyday numbers that we work with. All right, so let's do another example. All right, so let's do another example. And let's say in this example, I want to do 101101. All right, so how many bits is this? Let's count up how many bits. 1, 2, 3, 4, 5, 6. So this is a 6-bit number. Okay, so let's give weights. 2 to the 0. Okay, 2 to the 0, that's 1. 2 to the 1 is 2. 2 to the 2 is 4. 2 to the 3 is 8. 2 to the 4 is 16. 2 to the 5 is 32. One key item is if you're kind of bad about doing exponents, is how do you find this spot? Well, it's 2 times the number that came before it. So it's 2 times 1. That's 2. How do I get this number here? Well, it's 2 times what came before it. So 2 times 2, that gives you 4. How do I get to the next item? Well, it's 2 times what came before it. So that was 4. So 2 times 4, that's 8. And then this one, that would be 2 times the 8. So that would be 16. And then over here, this is 2 times what came before it, 16. So that gives you 32. So in case you're having a little trouble doing exponents, just start off with 1 and just keep multiplying 2 each way through. Okay, so we have this 1, 0, 1, 1, 0, 1. That's in binary, and I need to kind of know what number that is in base 10. Okay, so let's add this up. This is 2 times 32 plus 0 times 16 plus 1 times 8 plus 1 times 4 plus 0 times 2 plus 1 times 1. All right, so we get 32 plus 8 plus 4 plus 1. All right, so that is 32 plus 8 is 40 plus 4, 44 plus 1 is 45. So 101101 is 45 as our decimal. All right, so let's just figure out if we have an 8-bit number, what are the weights? Just so we can make sure everybody understands this. Okay, so we start 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, 2 to the 5, 2 to the 6, 2 to the 7. What numbers are these? It's 1. 2 times 1 is 2. 2 times 2 is 4. 2 times 4 is 8. 2 times 8 is 16. 2 times 16 is 32. 2 times 32 is 64. And 2 times 64 is 128. So that way you can kind of figure out what your weights are going to be. Okay, now there's going to be times when we're going to have a decimal number and we're going to want to know what it is in binary. Okay, so what we did so far in this example here, we did a binary to decimal conversion. Now what we're going to focus on is doing a decimal to binary conversion. So we're going to go in the opposite way. Okay, so let's say I have 53 in base 10, and I want to know, how do I represent 53 in base 2? Okay, so how do I do that? Okay, so let's start off with 53. And there's going to be a sequence of events we're going to do. So I'm going to do this 53, and I want to divide it by 2. And when we divide it by 2, we're going to get 2 different parts. We're going to get what our remainder is, and then we get what our quotient would have been, what our answer would be. So what is 53 divided by 2? Well, that would be 26, and that would have a remainder of 1. Then I'm going to divide 26 again by 2. All right, so that divides evenly. That gives us 13 with no remainder. Then I'm going to divide 13 again by 2. Okay, that's going to give us 6 with a remainder of 1. Divide 6 by 2. That's 3 evenly, no remainder. Divide 3 by 2, that's a 1. That would have 1 remainder. And then we're going to keep dividing until we get to a 0. So I divide 1 by 2, that gives me 0. That gives a remainder of 1. Now, what I'm going to do is going to take this number, and I'm going to write it out in reverse. And as we write it out in reverse, I would get 1, 1, 0, 1, 0, 1. And that's my answer in base 2. The key item is you got to write it out in reverse. Don't forget about that. All right. Let's do another example. Let's say I want to do 44 base 10. What is this in base 2? All right, so let's start with 44. What are we going to do? Take 44 divided by 2. And keep track of my remainder. This divides evenly, it's 22. Divide 22 by 2. Again, no remainder, that gives us to 11. Divide 11 by 2, that will be 5. We have a remainder of 1. Divide 5 by 2, that gives us 2 with a remainder of 1. Divide 2 by 2, that gives us 1 with no remainder. Divide 1 by 2, that gives us 0 with a remainder of 1. Remember, when we get to this 0 right here, that's the end. We got to get to a 0 at the bottom part. Then we're going to write our answer in reverse. So 1, 0, 1, 1, 0, 0. Okay, let's take this and let's verify using our binary to decimal. So I have 1, 0, 1, 1, 0, 0. What is that in base 10? All right, so let's do this. Starting off at the right side, that's 2 times 1, 0 times 1, plus 0 times 2, plus 1 times 4, plus 1 times 8, plus 0 times 16, plus 1 times 32. So let's add this up. That's 32 plus 8 plus 4. Well, 32 plus 8 is 40, plus 4, 44, and that is what we wanted to get to. Right? So 44, we said it was 1, 1, 1, 0, 1, 1, 0, 0. And then we verified that this is the actual number that we wanted. All right, we have one last topic to cover. And what we're going to talk about next are fractions. Okay, let's again start with what we know, our base 10. And on our base 10, let's say we had 24.37. All right, this has weight as well. The weight is, we had the 10 spot, 10 to the 1. We had the 1 spot, 10 to the 0. And then once we get past the decimal point, then we get to fractions. This would have been our 10th spot, 10 to the negative 1, and then our 100th, which is 10 to the negative 2. So we can say that this is 2 times 10 plus 4 times 1 plus 3 times 10 to the negative 1, that's 0.1, plus 7 times 0.01. So we keep adding a 0 after the decimal point, and that's going to start getting us to getting to fractions. Well, when we talk about binary, we're also going to have these fractional points. So let's say I had a 1011.101. All right, so that's 4 before the decimal. 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3. We had 3 after the decimal. That would be 2 to the negative 1, 2 to the negative 2, and 2 to the negative 3. All right, so how does this get added up? That's 1 times 8 plus 0 times 4 plus 1 times 2 plus 1 times 1 plus, now we're going to do the fraction, 1 times, well, what's 2 to the negative 1? That's a half, plus 2 to the negative 2, that's a quarter, plus 1 times 2 to the negative 3, that's an eighth, which gives us 0.125. So let's add this up together. That's 8 plus 2 plus 1 plus 0.5 plus 0.125. So that's going to give us 11.625. And that's what that number is in decimal. So again, this is how we're going to do binary to decimal. All right, so let's figure out how we're going to do decimal to binary. All right, so let's start with a number. Let's start with, let's say we're going to do 20.625. And what is this item in base 2? Okay, so what we're going to do is this is going to be 2 steps. First, we do the whole number. And then second, we're going to do the fraction. So we're going to do this in 2 separate pieces. All right, so let's do the whole number first. We'll start off with 20 divided by 2. That's 10 with no remainder. 10 divided by 2, that's 5 with no remainder. 5 divided by 2, that's 2 with 1 remainder. 2 divided by 2, that's 1 with no remainder. And then divided by 2, that's 0 with 1 remainder. All right, so now we got the whole part, 1, 0, 1, 0, 0. Okay, now we got to find the decimal piece. To find the decimal piece, we're going to start with what the number is we want. We're only going to look at the fraction part. We want to figure out 0.625. Okay, how are we going to do that? So I'm going to multiply the fraction part by 2. So 2 times 5, that's 0, 5, 2, 1. Okay, that 1, this is part of our answer. What we're going to do is we're going to take everything except the whole number, and we're going to put that as the next item we need to multiply. So we multiply this, that gives us 0.5. Again, we're going to keep this 0. Everything after the decimal point, we're going to move over so we can multiply again. We get 1.0. We're going to keep this 1. At this point, if we took this, this would be 0 times 2. We will always get 0. So it will always be 0. Now, this item here, we're going to write going left to right. So what was our whole part? Our whole part was 1, 0, 1, 0, 0. And then we're going to put each of these, the whole number part, 1, 0, 1, going left to right. Okay, sometimes you're going to get to items that it's not going to be made up of powers of 2. So let's say I have something like 0.7 in the base 10, and I want to convert this to binary. Well, I would say I'm going to give you information about the number of fraction bits. Okay, so let's say I want a total of 7 fraction bits. So we're going to do this a total of 7 times. Right, so I'm going to start with 0.7. I'm going to multiply this by 2. I get 1.4. Only keeping the 0.4 part. 0.4 times 2, that's 0.8. Okay, 0.8 times 2. So let me highlight the whole bits. Those are the ones I'm keeping. That's 1.6. 0.6 times 2, 1.2. Then I'm going to do 0.2 times 2, that's 0.4. How many bits have I done so far? 1, 2, 3, 4, 5. I need 2 more, so I'm going to do 0.4 times 2, that's 0.8. I'm going to do 0.8 times 2, 1.6. And that's going to give me 7 decimal points. So I can say this is 0.1011001 in binary. All right, so that gives us everything we need to know about binary numbers. Next time, we're going to look at what are called hexadecimal numbers and how those are get represented.